What's going on, happy people? All right, so tonight we are going to start our live coding of the 8 steps. Well, we're actually going to do 7 steps. We're not going to deploy our model just yet. And the whole purpose of this exercise is really just to walk you through, just to give you a bird's eye view of the machine learning process. All right, so ignore my messy desktop. The first thing you need to do, or you want to do, is to get into your terminal or command line. So I'm on a Mac. So for me, I'm going to get to my terminal by clicking this magnifying glass. I use iTerm instead of terminal. It's just a preference. You can use terminal, it doesn't really matter. However, I should point out that I'm using an older version of Mac, the Mac OS, so I'm still using Bash. And the reason for I'm bringing this up, for some of you who are on newer Macintosh computers, you might see Z or ZSH instead of Bash right here. It's the same thing. It's still a terminal, just a different interface or different type of command line. But in any event, or different shell, sorry, that's the word I was looking for. So in any event, so once you get to your terminal, you want to navigate to the directory where your files will be saved. So I have a number of directories. Let me just show you. Okay, so I'm going to cd for change directory, and on my keyboard moving up and down like this. All right, let me just get this level. Hold on, let me get this book out the way. So if I go to cd documents, right, then I'll be in my documents folder, and if I press ls, I think it's for list well, not contents, but list, yeah, list contents. I don't know what the S stands for. List subdirectories maybe. So anyways, ls gives you the list of all the stuff. Now, as you can see here, I have quite a bit of stuff. I usually just dump everything in DS Portfolio, right? Because basically everything I do is a portfolio piece, right? Well, otherwise, what's the point of doing it? Everything every piece, everything I've done, I just dump it on my website. It's just a whole process of me just showing my work. I even if it's messy, it's unfinished, I just throw it up on the site. So in any event, so once you navigate to the folder that you want, the next thing you want to do is to type Jupyter with a Y, not with an I, Jupyter Notebook. Right. This is assuming that you have already installed the Anaconda distribution package. If you haven't, please do so. If you need me to make a video on that, I can do that as well. But it's very easy. I believe I showed you in the last video how to navigate to Anaconda's website, download it, and if not, forgive me, I will post a quick clip with that. So from here, you're going to hit Jupyter Notebook and press enter, right? Then it does a whole bunch of little stuff in the background here, boom, and then you should have a Chrome or Safari or whatever your browser is pop up with this localhost :8888. That's basically the localhost server on which you will run Jupyter Notebook. So give it a while, depending on how new your computer is or how old your computer is. It might take a little bit. I don't know why it's taking an awfully long time. It's usually faster than this. Must be because I'm filming it, putting it on the spot. All right. But in any event, so it's going to pop up after some time. And after that is done, we will start the coding. Okay, so once Jupyter is up and running, the next step you want to do is to click New, then Python 3. Then you wait a little while. You get very patient once you start studying data science. Or anything you study, actually, you get patient. All right, so here we are. So this is a blank notebook. All right, so basically, how I like to start my projects, I like to start it pretty much the same way I start all my projects. I like to create an outline, right? It kind of just helps me to, just organize or frame what it is that I want to do. So Jupyter is one of the reasons I love Jupyter Notebook is because in addition to being able to code in this interface, you can also add markdown text. So for example, if I type, the title goes here, and then press escape M, the letter M, and then press shift enter. Voila. Actually, let me zoom this in. I'm blind as a bat. There we go. All right, so that will be my title. Then the next thing I want is my problem statement. So I'll say problem statement goes here. All right. Escape. Actually, I don't want this to be a title. I just want this to be regular text. So I just press escape M. Boom. All right. So you have your introduction and your problem statement, right? Problem statement, business problem, whatever you want to call it. The thing that you're trying to solve or figure out goes there. Then the next thing, after we get the title and the problem statement out the way, you can also, you can use the same paragraph to put some information about the data itself. So you can say problem statement goes here, information about the data sets goes here. So, basically just pretend you're doing this project for yourself and for a million other people. And every time somebody opens your notebook, they need to know what's going on. So they need to know, first of all, what's the name of this project. Then they need to know what's the problem he's trying to solve. And then it's always good to have information about the data set, right? And then after that, we get into the actual coding, or the actual, what do you call it? Yeah, the actual steps in the machine learning process. So the very first, actually we did the first step, we clearly defined the problem. So there's a secondary step or another step, right? And I'm so sorry, I'm using the word step so many times. But the next thing we want to do is to import our libraries and our data. So what I'm going to do 2 hashtags as opposed to one. One gives you a level 1 heading. 2 hashtag gives you a level 2. 3 hashtag level 3 heading, and so on and so forth. And I think it stops at 6. So, all right. So I do a level 2 heading. Then I say import libraries and load dataset. All right. Now we're not writing any code as yet. We're just kind of fleshing out, the stuff we need. All right. After we've imported the libraries and loaded our data set, the next thing we want to do, after we've run preliminary checks on the data set, the next thing we want to do is visually explore it. So I want to do some exploratory data analysis. Exploratory. Okay. And apparently cannot spell. Short is EDA. All right. So after we've explored the data, we visualize it. Next up we want to do is pre-process the data, or feature engineering. Feature engineering is a fancy term, but I prefer to put data pre-processing because, feature engineering just sounds like I'm doing a whole lot more than, fixing missing values and stuff. All right. So data pre-processing includes, and we can make a little notation for us here. This includes checking for missing values, standardizing the data, etc. Right? After we've pre-processed, the next step we want to do is to actually choose an algorithm and then train this algorithm. So the next step in this process is to train model. Actually, before we even train the model, we want to split the data set into training and test sets, right? Because you should always have a training set and a test set. Then after we've done that, then we can train the model. Train the model. After we've trained the model, then we evaluate the model. After we've evaluated the model, then we fine-tune the model. All right, or in brackets we can put fine-tune the hyperparameters, another fancy term, right? And then that's really about it. Let's go back to our slides and see if that covers the 8 steps or the 7 steps. Boom. Any day now, computer. All right, so I swear it runs slower when I'm recording, so it must be a resources issue. All right, so where are we? All right, so step 1, think about what you're trying to solve. Do we have that here? In fact, I have an idea. Let's do this. Let's do it this way. Let's put this right here. All right, and put this right here. All right, so how is that? So step 1, I know it's a little hard to see. So think about what you're trying to solve, which algorithm will you use. Boom. That's basically a problem statement. All right, step 2, all right, get to know your data. So that's why I said import libraries and load data set. It's not really a step in the whole machine learning process, but you really can't go anywhere if you don't have the libraries on you. So it's kind of like a step 0, right? So you can call this step 0, just kind of preparing to start your actual steps or a pre-planning step, whatever you like to call it. All right. So step 3, visualize your data. Boom. Step 4. Clean the data, right, or pre-process, right? Step 5, choose an appropriate machine learning algorithm, specify performance measure, and train the model. Now, I know it looks a little funky here, but believe me, in when you're actually coding, these are the steps you follow more or less. Because a lot of these things you kind of, it's iterative, it's not like linear, boom, 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 right? Because after you pre-process your data, you might realize that, hey, you might have to go back to this step and get new data, right? You might find that either the data set that you're working with is not appropriate, or it might be appropriate, but you just need a whole lot more data. All right. So, things happen, and, you move back and forth in between these steps. But more or less, after you finish step 4, right, you're going to, which is cleaning the data, you're going to move on to basically, model training, right? And before you could train the model, you need to split your data set into training set and test sets. All right, and then step 6 is to evaluate the model. All right, and and evaluate the model basically using the performance measure that you specified in step 5, right? And then step 7, fine tune the model. All right, and then that's it. The whole the process is actually quite simple, right? Like I said, the devil's really just in the details, right? Your data and your algorithms, right? So how appropriate your data is and how appropriate your algorithm is. So both need to be working in, you think of it like a synchronized swim or synchronized dance, right? So your algorithm you need to pick the right algorithm, you pick the right data set. The data set needs to be processed in a way that's appropriate for the problem you're trying to solve. And so that, like I said from the first video, problems usually arise either from one of 3 things: either bad data, bad algorithms, or bad data and a bad algorithm, in which case you should just throw everything out at the start. Start fresh. All right. So this is our template that we'll be working with. And now let us load up some data.